So applications of sine and cosine functions. What we're going to do today is look at transformations of being able to identify what the A, B, C, and D values are. And we're going to do it by looking at cosine and sine waves on each of these. Because the fact of the matter is, so sine and cosine waves look a lot alike. It's just about, do you want to call it a cosine wave? Because then the numbers are a certain number, or do you want to call it a sine wave and it shifts over and the numbers are going to be different, but they can still show the same exact wave. Okay? So what we're going to do is we're going to look at this first graph and concentrate on this center line. Okay? This is that equilibrium that we were talking about from before. So from this equilibrium, which of these letters does it represent? It represents D. So my original graph, remember sine and cosine, they're going up and down, up and down, up and down. And the middle line originally is called the x-axis. Otherwise, y is equal to 0. What would D be in this graph that you see right here? This is going to be 35 because it was shifted up 35 units. Okay, so all the way to 35. Any questions on that? Okay, so the next one, in my opinion, that probably would be easy to find would be the letter A. And the letter A is looking at basically the length between equilibrium and a max or equilibrium and a min. It means the same thing. What would that number be? 25. Okay, so now what we're going to do is we're going to look at our period so that we can solve for B. They go hand in hand. And the way we can see when something repeats is that we're going to look at, let's say, a maximum and see when again would the next maximum occur. So we're focusing on this right here that gets drawn, and the period is going to reflect from right here on the x-axis all the way to right there on the x-axis. So if you look at it, this first one starts, because here's 1, here's 2, 3, 4, 5, 6. So it goes from 0.5 all the way to 6.5. So what's the period? It's going to be 6, right? So it's going to be 6. It goes from 0.5 all the way to 6.5. Now, the B value, we have to know that the fundamental period for cosine and sine is 2 pi. So this equation is very important. The fundamental is always going to be 2 pi. And 2 pi divided by B is your new period. We know the new period on this graph as being 6. That's what we solved by looking at the graph. So now if I'm going to solve for B, what does it look like B is going to end up becoming? 2 pi over 6. So these switch, or you multiply both sides by 6, or sorry, both sides by B, and then divide both sides by 6. And 2 pi over 6 will reduce to pi over 3. That is my period. Or sorry, not my period, my B term. Okay? Now, the phase shift for cosine. We're trying to see where did it shift. Did it shift to the left? Did it shift to the right? Let's look at a cosine graph. You know that cosine looks like this. Because remember the whole snow cone cosine for 1? So it has a reflection at 1. And we want to see this as far as, let me highlight for you where that would be in the graph that we're looking at over here. It would look like this. There is one complete period as far as cosine goes. And it looks like it shifted over how much to the right? Just 0.5, right? Because it used to be right in the middle of this max right here, but now it's here. So it shifted to the right 0.5, because again, remember the scale of these numbers down here, so we're going to say C is 0.5. So now that we have all of our letters, we can say A is 25, so that's my vertical stretch, if you will. B is 0.5, or sorry, not that, pi over 3. And C, this equation is always going to be x minus C. So C was a positive, so we could put 0.5 or 1/2, however you want to write it. And then it shifted up 35. Because we're doing A, B, C, and D. Okay, so now looking at my equation, right here I have x minus something. That means it shifted to the right 0.5 units. Does that make sense? Because remember, with the x, it's always the opposite. Okay, so same graph, but this time we're not going to look at it as a cosine graph. We're going to look at it as a sine graph. And let me show you what we're going to do there. So here's my sine graph over here to the right. And here's one complete starting period of sine. And I want to see what that looks like over here. So you got to know your parent functions for cosine and sine for sure. Those are the only two that you have to know. Just have memorized. What do they look like on the graph? Okay. And now you saw the center of this graph pretty much is here. Now has moved to here. How much did it move, and in what direction did it move? -1. So C for this one is -1. What is the A value on this one if I'm looking at it as a cosine? Or as a sine, I'm sorry, as a sine. What's the A value? Still 25. What is the B value? It's still pi over 3. And last but not least, yes, the shift is still 35 up. But this time we're not going to put x minus a -1. We're going to change it to what? +1. Because it's shifting to the left. It's always opposite of what you see with that x. Are we good? Yes?
So for sine, will the graph always start going down before it gets to...
So here's the thing. With sine, what visual that I want you to put in your brain for sine is just this one right here. Okay? And you can shift it left or right. So you could call any graph, you could call it, that looks like this of course, you could call it a sine or a cosine graph. You just have to see how much am I willing to account for that C value that shows that phase shift left or right.
But the period starts on the downward.
Yes, the period for sine starts downward. And the period for cosine, oh, there, I see what you're saying, is upward. Okay? All right. Let's do the next one. What letter should we start with? D. So, right now, how much does it look like it shifted and in what direction? 5 up. So we're going to say 5 up because here is my equilibrium at y is equal to 5. Okay? Now, the next one. Which one would y'all look at? A. So A is going to be, again, from equilibrium up or from equilibrium down. The same thing. What does that number look like to you? 15. Nice. So that's going to be A. So let's go ahead and write that over here on our equations because that's that vertical stretch. Okay? Now, I'm going to go ahead and write that D on both the equations because it's shifted 5 units up. And then now let's go ahead and solve for the period. Okay. The period on cosine and sine, again, are both 2 pi. So I'm up here saying 2 pi over b. But we have to figure out what exactly is this period so that I can solve for b. You with me? We're figuring this out right here on the graph. How did we do it in the other one that we should do it here? Between maximums, right? You could do it either between maximums or you could do it between 2 minimums. Either way that you do it, you're trying to find the horizontal distance that creates that wave. Okay? So if we did these minimums here, it looks like it goes from 4 to what? 8. I know it's a little bit off, but it goes from 4 to 5, 6, 7, 8. So the period is 4. That is our new period that we're going to be able to now solve for b. Here we go, multiply both sides by b. We get 4b on the right. We get 2 pi on the left, so when I divide by 4, I get pi over 2. So that's my period, pi over 2. And that's my b term. That will go for both of these.
Wait, how do you get pi over 2?
By setting our period that we found from here as our new period, and this equation we have to have memorized. This one won't be an equation that we give you sometimes. This one you got to know, okay? So it'd be 2 pi over b is equal to 4. And then we solve for b. If it was tangent, you're going to learn soon, it's not 2 pi, it's just pi over b. Okay? All right. So now we have to find our c term. But we have to see it 2 different ways. C term, see it 2 different ways. Cosine and sine, let's look at it cosine first. So just like we were talking about with Jeremy earlier, cosine goes up first. So I could look at this as that is a wave of cosine. Right? So what did the wave of cosine originally do, left or right? It went to the right. So it went how many? 2. So 2 is my c term, and I'm going to write x minus 2, which makes sense. Because if it's x minus 2, it means shift 2 to the right. Yes?
Would it still work if you used if it goes to the left?
So if it moved to the left, you would put c is equal to negative 2, like we did over here. And whenever you put it in the equation, it'll say x minus the negative, which is x plus 2 in that case.
No, I'm saying like, let's say you set it up to like the one on the left.
Oh, I see what you're saying now.
Yeah.
He's saying, let's say we said it was, you're saying this one right here.
Yes.
So you know here's where it started, and it shifted left 2. So if it shifted left 2, this could also be x, minus a negative 2. So it could be either one. Nice. That's rare for that to happen, with a plus or minus, that you know what I'm saying?
Yeah.
That it would still be equivalent. But the key is going to be a little bit different, because some of you may do what Diego just did and shift left, and we have to make sure that that's okay. You see what I'm saying? And some of you may shift right. It's still in phase with it. All right, let's look at the next one. The next one is talking about sine. And I know sine goes like downward first. So I'm going to go and find my equilibrium, and there's a good sine graph right there. Okay? And that's over here. Now I know the center usually lies right here, right in the middle of that, which has now been shifted all the way over here. What is c going to be on this one? 1. So it'll be x minus what? 1. Which makes sense, because if it's x minus 1, moves to the right 1. Because with the x, you interpret the opposite. Okay? Any questions from what we just did? Okay. So now let's go to, well, this is number 10, just with answers. Let's go to the application. It says the population of prey in a predator-prey relation is shown. Time in years since 1985. So right here is 1985. 20 years later is 2005. You with me? Okay. It says determine the max and min values of the population to the nearest 50 and use these to find the amplitude. Okay? So what are the max and min values? What do you see as being the maximum?
Like 850.
850? And what do you see as being the minimum? 250. Okay? And we want to find the amplitude. So some people, they like that nice equilibrium because then they go up and there's their answer. But when you don't have the equilibrium established, it's almost like you have to find it. So you're going to average them, right? You're going to add and divide by 2. So if I do 850 plus 250 and divide that by 2, what is it that you get? Oh, wait a minute. I did something wrong. No, I did not. So 850, 250, add them up together, you get 1100, right? Divided by 2 is 550. I don't know why I said I did something wrong. Here's your equilibrium at 550. So if that's my equilibrium, you see what I'm doing? So what would my amplitude be? If 550 is my D value, in other words, right? What is my A for amplitude going to be? 300. Because it went from here to here, it had to be 300 that was added. Okay, so 300 is said amplitude. Questions? Okay. B says determine the vertical shift as far as C goes. So cosine starts at a max point, and what is the vertical shift going to be that you see? Say again? 550. So that is going to be, oh, these are a little bit off. That's why. This vertical shift should be D, and the phase shift should be C. Ah, that's off. You see what I'm saying? The phase shift is left to right, and the vertical shift is that D, displacement. And what did y'all say that the vertical shift was? 550. So D is 550. The phase shift, how much did it move left or right? And that's the question. Do y'all want to use, did it say to use cosine? It doesn't specify. You can use whatever you want. And even though it says sinusoidal, that's big. You don't have to use sine. You can still use a cosine. Sinusoidal just means it's oscillating up and down. Okay? Since Jeremy said it, let's use cosine. So if I'm looking at it as cosine, I know that it's going to go up first. And I just highlighted one entire period. And what does the shift look like it did, and in what direction did it go? It's almost 2 years. It's like 1.5, right? To the right. So you're going to say C is 1.5. Because when we put in the equation, we're going to have it as x minus 1.5. Okay? Determine the period. Okay? So again, the period, you can go between 2 maximums or 2 minimums. You could even go between 2 places where it's in the middle if you wanted to. But I think it's easiest to see from max to max or min to min. So let's go ahead and look at, let's say from this max all the way to that max. And we're trying to see how much did it go. So what does it look like it started off at? 1.5? And it looks like it went all the way to what? 7.5? So what would our period be? 6. So our period is 6. Like we were talking about with McKaylee earlier, it's 2 pi over b is this 6 that we just found. Right? Now we're going to solve for b down here. Whoops. Simply by multiplying both sides by b, so that we get 2 pi is equal to 6b, and then dividing by 6 so that we get b is 2 pi over 6, which reduces to pi over 3. So my b term is pi over 3. Now if I build my equation, it's going to be a So we were going to say f of x is a cosine, because Jeremy was wanting to do cosine, which is fine. We're going to do bx minus c, and then at the end it's plus d. And some of you have asked this. Yes, there's a huge parentheses right there because this entire thing is basically the angle, if you will, cosine of theta. Okay? So if I wrote this all out, help me out, what would I put as my final answer? F of x is equal to what? 300 times the cosine of pi over 3, nicely done, times what? Minus 1.5, and then plus what? 550. Nicely done. This right here would be our equation. We good? Alright, so if you need to watch the video, please. I know 6th period's going to have to because it didn't flow as well as that just did. But there's the video for you if you need to find A, B, C, or D.